Hello everyone, in this video we're going to be solving a quartic equation. We've done some quartic equations before, and this equation is particularly important because of the trick that we're going to use to solve this problem. Okay, so I'm going to show you a method to solve this equation, and then at the end I'm also going to be showing you another method that we can also use. So you'll see two methods today. Okay. At this point, you can just pause the video and try this problem yourself first, because then watching the solution will be more fun and beneficial. All right, let's get started. Now, I do have x to the fourth power plus 26x squared minus x plus 182, which is equal to 0, and we're supposed to solve for x. Awesome. Now, quartic equations are not very easy to solve. There's a quartic formula, which depends on the cubic. And cubic formula is complicated and quartic is much worse. So we're definitely not going to use the formula here. We're going to use some tricks. Okay, now, first of all, notice one thing about this equation, which is particularly important, that we do not have x cubed. So this could be considered a reduced quartic, which is what we have to do if we're going to solve this equation by using the formula. So it's good to have that. And when I show you the second method, you'll understand why it's important not to have the cubic in our equation. All right, let's get started. So what am I going to do? Well, I'm going to take advantage of the fact that the first two terms gives me the impression that this could be turned into a perfect square plus minus something, which is a good thing, because if I can express one side as the square of something and then the other side as something else, hopefully maybe I can get difference of two squares from here or something like that, you know. I'll just give it a try and we'll see what happens. Okay, so what I'm going to do is then add the appropriate term, which is 169. Why? Because I can make it x squared plus 13 quantity squared, right? Awesome. And that will be a good thing to have, right? Maybe, maybe not. Let's see. Okay. What about the rest of the expression? Well, I could add the 169 and subtract it, which is equivalent to breaking down the 182, because 182 is greater than 169. So I can just go ahead and proceed. Minus x plus 13, which is equal to 0. Awesome. What am I going to do then? Minus x plus 13 is equal to 0. Beautiful. Now, what is so beautiful about this equation may not be very clear to you at this point, but you probably noticed that I have the 13 twice in the equation. But this is not a perfect square, right? Even if I add something to both sides and put it on the other side. But let's see what happens. So that's the next step. I'm going to go ahead and add x minus 13 to both sides, and that's going to give me x minus 13. Beautiful. And again, at this point, this may not still be clear to you. So what I'm going to do is, first of all, notice that the left-hand side is always positive. Therefore, the right-hand side should also be positive if we're looking for real solutions, which means that I can actually square root both sides, right? It's going to be safe because we won't have the absolute value on the left-hand side, and the right-hand side is going to be nice. Okay, so let's go ahead and do that. If I do it, I'll be getting x squared plus 13 being equal to the square root of x minus 13. Okay, great. Now, at this point, it may or may not be clear to you, but we're going to be using a very extraordinary transformation here. So what do you notice about this equation? Well, if you look at this very carefully, hopefully you've noticed that these are two inverse equations. What is that supposed to mean? Well, the inverse of the function x squared plus 13 is the square root of x minus 13, and the inverse of the square root of x minus 13 is equal to x squared plus 13, which means that f is equal to f inverse. Well, this is not always true, because otherwise, if a function is always equal to its inverse, then it should be the identity. But we're kind of talking about a particular point at which these two values are equal. And as you know, f and f inverse are symmetrical with respect to the diagonal y equals x, which means they will only intersect at y equals x. But let's explore a little bit more. Let me explain more what I mean by this. So I'm going to go ahead and set this equal to y, and then you will see in a little bit why I do that. Okay, so from the second part of this equation, I get x minus 13 is equal to y squared if I square both sides. And then if I go ahead and add 13 to both sides, I'll be getting x equals y squared plus 13. Awesome. Now this is one of the equations that I get, but indirectly I also get something else, which gives me y is equal to x squared plus 13. Beautiful. Now if I take this as a system, I'm going to be getting something real nice. Why? Because it's going to be nice. You'll see in a little bit. Okay, so let's go ahead and work this out. Let's change our color here a little bit. All right, let's see what happens. So what am I going to do for this system, right? Well, since I have some type of symmetry here, I can actually go ahead and subtract these equations side by side, right? So that's going to give me x minus y, if I subtract this way, is equal to y squared minus x squared. Obviously, 13 is going to cancel out. Then what I can do is I can put everything on the same side. So let's go ahead and add this guy over here. Of course, everything will be negated, right? It's going to be 0. And notice that this can be factored by grouping. So if I just go ahead and x minus y out, then I'll be getting 1 plus x plus y, which is equal to 0. Beautiful. Now, this is an equation that I obtained from a system of equations, which I obtained by substitution. Again, so I had one equation, then I turned it into a system. Now, I turned it into an equation again. But this is much better. Even though I have two variables, this is a really nice equation to work with. Why? Because from here, I get really nice results. Let's see what happens. So the first one gives me x equals y or y equals x. But what is y? All right, let's go back here and take the equivalence of y here. Y is equal to x squared plus 13. So let's go ahead and replace y with that. So this is going to give me x squared plus 13 is equal to x. Beautiful. Then I'll get the quadratic x squared minus x plus 13 is equal to 0. And hopefully I can go ahead and solve this equation. Let's leave that up there. And let's go ahead and take a look at the second solution, which comes from here. And that gives me what? X plus y is equal to -1. And as you know, y is equal to x squared plus 13. So this gives me x plus x squared plus 13 is equal to -1. Again, this becomes a quadratic. All right, let's go ahead and do that. This gives me x squared plus x plus 14 plus 1 is equal to 0. Okay. Awesome. So what am I going to get from here? My goal was to solve for x, right? Okay, so we got two quadratics, which is nice. Then we can just go ahead and solve each one separately by using the quadratic formula, and then we can find all the solutions. All right, let's go ahead and do that. And then I will be explaining the second method. All right, let's see what happens. Here I do have x equals -b plus minus the square root of b squared, which is 1, minus 4ac, which is 4 times 13, and then divide everything by 2. Awesome. Let's go ahead and simplify this. But what happens is, unfortunately, or maybe fortunately, because we'll get some solutions, they're not going to be real, but that's okay. We'll get a negative discriminant, right? Which means we have non-real solutions, but that's okay. So how do we write this? We're going to get the square root of -51. So I can write it as, and 51, by the way, does not contain any perfect squares. So there's nothing I can do about it. Sorry about that. It's going to be 1 plus minus the square root of 51i over 2. That's going to be my two solutions. And the other two are going to come from here. If you want, you can call them x1 and x2. You know, I just don't want to bother. -b plus minus the square root of b squared minus 4ac, which is going to give me 56. All right, divide by 2. And from here, as you know, 1 minus 56 is -55. And -55, actually, it doesn't really contain any perfect squares. So we're going to have to write it as square root of 55 with the I, and that's going to give us the other two solutions. So my other two solutions are going to be negative 1 plus minus the square root of 55I over 2. So basically what did we do here? We basically solved this equation, the quartic equation, and we found all the solutions. Unfortunately, none of them are real, and that can happen with quartic equations because they are of even degree and they don't have to have real solutions. Okay, cool. Now, these are all the solutions. So basically, this is our first method. Now, let's talk about the second method that I mentioned at the beginning. So my original equation is what? X to the fourth plus 20x squared minus x plus 182. So let's go ahead and write that down. Again, x to the fourth plus 26x squared minus x plus 182 is equal to 0. Awesome. Now, we don't know if we have real or solutions or not at the beginning, right? There are ways to check this, but let's not get into that right now. We could check for rational solutions. We can exhaust all the possibilities, or we can look for rational solutions, so on and so forth. But that's not what we're going to do here. Remember, I told you when the x cubed is missing, it is a good thing. So what do we do in that case? Well, here's what I'm going to do. If there are some solutions, hopefully I can factor this, right? And you will notice that it's factorable. Maybe you already did. So what I'm going to do is I'm going to try to write this equation as follows. X squared plus ax plus b multiplied by x squared minus ax, and I'll tell you in a little bit why that's the case, plus c. And I want this to equal my expression, x to the fourth plus 26x squared minus x plus 182. If I'm able to do the factoring, then I can solve each quadratic, which we actually already did, right? But let's go ahead and just play it out. So what I need to do here is, let me explain why I put ax and negative ax. Because we don't have an x cubed term, I want x cubed to cancel out. And that can be achieved by using opposite coefficients on the x and 1x squared, because when you distribute this, you're going to notice that you'll get negative ax cubed plus ax cubed, which means that we're not going to have any x cubed terms. Okay, and that's not going to hurt anything else because everything else looks good. Awesome. Let's go ahead and distribute this then, just ignoring the x cubed along the way. So I'll be getting x to the fourth plus cx squared. Obviously, we're down here. And then if I distribute to ax, that's going to give me negative a squared x squared plus acx. Again, I'm ignoring the x cubed terms, plus bx squared minus abx plus bc. Beautiful. And that's going to equal our expression, but let's simplify this a little bit. So I get x to the fourth. For the x squared term, I'll be getting b plus c minus a squared times x squared. And for the x term, I'll be getting ac minus ab. And then my constant would be bc. Now, if you set this equal to this expression here, then you should be getting the following. Let's see what happens. Well, if this equation works, if it's factorable this way, and it's always factorable this way, even though ABC may not be easy to find and they may not be integers, but it's always factorable. So this guy needs to equal 26. This guy needs to equal negative 1. And this guy needs to equal 182. Okay, so here's the thing. I have 3 unknowns and 3 variables, which means we can solve this hopefully as a system. But let me just show you a method to solve it. I'm not going to finish it up because I don't want to make this video too long. The geometry puzzle yesterday was, you know, kind of too long, right? I didn't realize it was going to be that long, but thanks for watching that video as well. If you haven't watched it yet, go ahead and watch that video from yesterday. Awesome. Let's continue. So this gives me b plus c minus a squared equals 26. This guy here, I want to factor out the a, because that would be good, you know, and then I have this. Now, so I'm going to kind of turn it into a vieta for b and c. So I'm just going to ignore a at this point and consider that I'm going to pretend that a is a constant, then I know the value of a. And this gives me something nice because look, b plus c is going to be a squared plus 26. From here, I'll get c minus b, which can be written as negative 1 over a. And then I got bc here. Look at that. Check it out. I have the sum, I have the difference, and I have the product. Beautiful. Now what I can do here is then, no, that's not what I wanted. Okay, I can just go ahead and add these up, cross out the b's, and I get the c's. 2c is going to equal that, a squared minus 1 over a plus 26, which I can make a common denominator for, a cubed plus 26a minus 1 over a. Then I can divide both sides by 2, and I'll be getting a cubed plus 26a minus 1 over 2a. So I was able to express c in terms of a, and then I can just go ahead and plug it in here, or I can subtract these equations and get the b in terms of a. Similarly, then I can go ahead and take those and plug them in here. Now, let me tell you what happens when you do that. You'll get like 6 power, but don't freak out because that equation is actually going to be easy to solve. You're going to realize if you do it, but I'm not going to go ahead and finish it up because that would take too long. And we already got the solutions. But let me tell you something. Once you find the values of a, b, and c, guess what's going to happen? You're going to find these guys here. So you'll have the same thing. And the solution is similar. Awesome. Okay, that's it. I think I'm going to stop at this point. Thank you for watching. I hope you enjoyed the video. Please comment. Let me know what you think about the video. And it's okay if you dislike it, but let me know what you think. If you dislike the video, tell me why you dislike it. But I think you're going to like this video. Comment, like, and subscribe. And see you in the next one. Have a good one. Bye-bye.